Welcome to the AI Research Roundup. I'm your host, Alex. Today is May 8th, 2025. We're looking at an ICLR conference paper published just over 3 months ago, titled Classic but Everlasting: Traditional Gradient-Based Algorithms Converge Fast, Even in Time-Varying Multiplayer Games. This paper explores how two classic algorithms, extra gradient, or EG, and optimistic gradient, or OG, cope when game rules change over time. These are gradient-based algorithms, methods using directional cues to find good solutions. The research asks if they reach a good final state, known as last iterate convergence, using constant step sizes, that's fixed adjustment amounts, even if the game conditions shift but eventually stabilize. Alright, so this figure actually shows us the mechanics of these extra gradient and optimistic gradient algorithms we've been discussing. On the left is extra gradient, and on the right, optimistic gradient. Both are shown as iterative processes, starting with an initial strategy, let's call it z_0, and using a constant step size, eta. They then repeatedly update this strategy based on the game's current conditions at each step k, represented by f_k of z_k. That pi_z symbol you see, it's a projection, basically making sure the chosen actions stay within the game's allowed set of strategies, z. Okay, so building on how these algorithms work, Figure 2 here shows us 3 plots. These plots illustrate the performance of the extra gradient algorithm across 3 different examples. On the vertical axis, we have something called the tangent residual, or r_tan. Now, the tangent residual, it's a clever way to measure how close the algorithm is to reaching a stable solution, what's known as a Nash equilibrium, a point where no player can get a better outcome by just changing their own strategy. And as you can see, in all 3 examples, this tangent residual value decreases over time, which is shown on the horizontal axis. This downward trend is really good news. It visually suggests the algorithm is indeed converging. Now, following up on the extra gradient results, Figure 3 shows us very similar plots, but this time for the optimistic gradient algorithm, again in these time-varying games. We're looking at 3 examples, and on the vertical axis, it's that same tangent residual, r_tan, our measure for closeness to a stable Nash equilibrium. Just like before, across all 3 examples, this tangent residual value drops over time, which is plotted on the horizontal axis. This consistent decrease for optimistic gradient, much like we saw for extra gradient, really supports the idea that these classic algorithms can indeed find stable solutions, even when game conditions initially change but then settle down. So, to wrap up, the main takeaway is that these well-established methods, extra gradient and optimistic gradient, really hold up. They achieve last iterate convergence, finding that stable Nash equilibrium, even when game conditions shift. This happens as long as these changes, or perturbations, are bounded and eventually diminish. And crucially, their convergence rates, which describe how quickly they zero in on a solution, are shown to be fast, around an order of 1 over the square root of t, where t is time, plus terms related to how quickly these game perturbations fade. This is a significant step, showing these classic approaches are reliable. Thanks for joining us on the AI Research Roundup.